Great, recording is rolling. Welcome to Friday, November 12th. A bunch of guys just turned in your momentum homework, so thank you for doing that. You guys' momentum quiz is due Monday. You've had this for a few days, so you guys have already turned this in. In case you missed it before, for whatever reason, a couple of small corrections. Number two, I listed one of the measuring tool devices as triple balance beam, and it should have been triple beam balance. That's the sort of thing that I could totally see an AP grader actually counting off for. And number four, there's a problem of two guys throwing a snowball back and forth. And the correct answer choice is off by about 1%. I went home and checked the answer over the weekend. It's off by about 1%. So if we're keeping the question, it's kind of tough. Whichever one's the closest, it would be a very close answer. So there's that. I'm going to get you guys set up with a lab today, but let's look at what we're doing for the rest of the semester. So when you guys come back next week, we're going to start rotational dynamics. We've done a little bit of rotation stuff, but we're going to do all the, we will do more of this. It's going to take us a few weeks. November 22nd through 26th, we get that full week for Thanksgiving. Yeah, so yeah, no school that entire week. Then when you guys come back from that week off, we'll finish rotational dynamics, take us another couple weeks, and that'll lead us straight into midterm review and exams, and then, then the break. Okay, so today, coefficient of restitution lab, I've got a question for you guys. How bouncy is the ball? Wait, what do I mean, the ball? There's lots of different ones back there. So you and your teammates pick a ball. Hey look, we got the bouncy balls are back. Got those. I got some racket balls back there. There's some tennis balls. There's some golf balls. There's lots of different. Ooh, there's even this guy. So pick your favorite one. And how bouncy? Well, maybe a more scientific physics way of couching that is, what is the coefficient of restitution? And then it would have to be between two specified surfaces. Maybe it's between the some specified ball and the tile floor would be another good option, right? And so remind you guys what this is. Now, this is not a concept that really made AP's list. AP doesn't really care about this concept, but I do. You guys can learn about it. And this is an AP level type lab in question. So. Yeah. So coefficient restitution is what is, if two objects collide and bounce off each other, what is the post-collision difference of velocities compared to the pre-collision difference of velocities? Take the absolute value, because otherwise it usually turns out to be naturally a negative number. But yeah. Now something like this. What's the coefficient of restitution? Well, what's the post-collision velocity of that bounce? 0. 0 divided by anything is 0. Okay, so that was one of the boundary conditions on coefficient restitution, right? What was the other boundary condition? It must be at least 0 and as big as 1, right? And that's if it boing bounces perfectly so that this is equal to this. Okay. Let's take a look at what I gave you guys here. So, look at this little diagram. You drop from some height, it's going to have some crash speed. It's going to rebound at some rebound speed, and you go up to some rebound height, something like that. All right, so I'm giving you guys this. Because, sorry, what leads to this? One more thing. If one of these objects is the floor, then wouldn't the pre and post collision velocity of that object just be 0? Right? Okay, and since you guys are bouncing the ball off the floor, then it just boils down very simply to this. So I'm giving you guys this expression. You're allowed to know that coefficient restitution is rebound speed compared to crash speed. You're allowed to know that. And you are also allowed to use one measuring tool, and that is a meter stick. So all you have to measure is a meter stick. Okay, so how are you going to, thank you. How are you going to figure out how bouncy the ball is, coefficient restitution, using only the meter stick? Okay, so here's where, ideally, I should just say, go figure it out with your teammates. But since it's Friday, short day, yada, yada, whatnot, I will give you guys this sort of cheat sheet. Here is coefficient restitution lab write-up. You got, I'm gonna have you guys do a full write-up for this. I'll put out some extra paper in case you don't have paper. So the 5-part write-up that we normally do: question, measuring tool, data gathering procedure, analysis, and then conclusion. So the question for everybody is, what is the coefficient restitution between whichever ball you pick and the surface you're bouncing it off of, probably the floor. Okay? Your conclusion has to match that question. So your conclusion better be coefficient restitution is like some value. Okay? You're allowed one measuring tool, and that's the meter stick. Okay? And then, okay, well, how are you going to figure that out? Okay. So there's 3 ways I can see this lab ending using just a meter stick to figure out that question. You can figure this out all using equations or graphs. And if you do a graph, there's 1 or 2 ways you can go with that. So see if you can figure this out all on your own ahead of time and write it down on a piece of paper. But if you need to something to look at, then that can help you out. I think that's all I got for you guys. You guys got any questions? All right, so I'll be around helping you guys out.